Okay, so we haven't been able to record videos for a while. I apologize. Just I had to do some microphone fixes. Something broke back there, but I blamed a person for it. Turns out they didn't do it. I thought for sure Mr. Durban had come to use my microphone. So I checked with him. I said, because I actually bought him a piece to fix his microphone as well. And when I gave it to him, I said, I noticed you borrowed my mic that one day. He said, no, I didn't. So I have no idea how it happened. Maybe somebody just tripped on the cord and it kind of yanked it out. I'm not sure because I do leave this laying around sometimes, right? So, but I won't get mad at you if you break something back there. Just let me know. So maybe I did it, but I just don't remember it. So anyway, let's go over some other rules. For example, if you want to find the derivative of f plus g, just take f prime plus g prime. Now, for example, if you had f of x is equal to 3x squared plus 2x, we did that rule last week. The derivative is 6x plus 2, right? So we've already done this before. But what we haven't done is the multiplication and the derivative. So do not write this down, but a lot of people, when they take the derivative of f times g prime, they will write it like this: f prime times g prime. Don't do that. It's not correct. If you want to see the proof of this, check out your book or come see me after class. I'll show you. But it's f prime g plus g prime f. That's how we do it. If you want to know the quotient, it's very similar. F prime g, g prime f. What do you think goes in the middle? Minus. And then it's got this weird thing. It's got a g squared on the bottom. So you have to see the proof if you want to know exactly why that works out the way it does. We already did the deriving of the power rule. That was the one proof I kind of wanted to show you so you could understand that it wasn't magic that we came up with that. We just simply expanded using Pascal's triangle, and we had a lot of fun with it. So flip it on over, and let's do some problems here. Wait a minute. What? Do what? Oh, when I answered the phone? That was me. She copied me. Ask her if she wants to be like me. We will. We will. All right. We'll ask her. Okay, here we go. Differentiate the following function. So you can see here that we have two functions divided by each other. The rate of change here is 2x, and on the bottom it's 1. If you take the derivative of the top, you get 2x. Take the derivative of the bottom, you get 1. So because you have those different rates of change, you have to use the quotient rule, and we will do so. So we take the derivative of the top. What's the derivative of the top? 2x times the bottom left alone. I am using this right now. F prime g minus g prime f all over g squared. Okay. All right, minus, what's the derivative of g, or the bottom function? 1 times the top left alone, all over the bottom squared. Now, if you could combine like terms, you should combine like terms. Get a 2x squared minus x squared. Just be 1x squared, right? And 2x times a negative 1 will give us a negative 2x. All over x minus 1 quantity squared. Done. That's it. That's it. Yep. Yeah, so number 13, I was able to do, remember number 13 from your worksheet that I wrote up the solution key for? That problem I was able to do in about, it took me about 5 minutes, I'd say, probably more like 2 minutes. when I was actually doing it using shortcut rule. But we did use the quotient rule, but we also had to use something called the chain rule. And the chain rule you won't work till next unit. So for example, I'll show you guys how to do this. 3x squared minus 1 to the 98th power. I'll show you to take that derivative without expanding out 98 times. Okay. All right, this next one. This one, I use the product rule. F prime g plus g prime f. So when you take the derivative, we take the derivative of 2x squared minus 6, which is 4x times the next part left alone, 5x squared minus 2x, plus 10x minus 2 times 2x squared minus 6. And we're just going to leave it. Okay. Yep, I know that right now it seems like, why would we just leave it? The fact is, you guys, you're never going to really see a function that's written like that, okay? They would normally just multiply it out as a polynomial, but we have to give you something to practice right now for the product rule. So like, well, when would we actually use the product rule? Well, here's an example where you would use the product rule. Say f of x was equal to 3x squared times the cosine of x. Well, there's the product rule. You have the derivative of 3x squared, the derivative of cosine. The only problem is we don't know the derivative of cosine yet. So we'll have to get to that at a different time. So don't worry about simplifying that, okay? Let's get rid of D. Let's do C. Do you think we'll use the quotient rule or the product rule? Quotient rule. Yes. As far as whether we use the quotient rule or the product rule. If you see the dividing, we're going to use quotient. If you see multiplying, we'll use product. As far as this, yeah, so you want to start to commit that piece kind of to memory. Yep. Go get some brain food. We'll continue when we get back. Okay, so let's get back to Allie's question. Yeah, you do want to try to commit these to memory as much as possible. So we're going to take f prime g minus g prime f all over g squared. So let's start with the top. What's the derivative of the square root of x? Do you remember that from our checkpoint? 1/2 x to the negative 1/2. So it ends up being 1 over 2 roots of x. And the quicker you can commit that to memory, the better off you'll be. Minus, what's the derivative of x? 1. Times, what? What's g? Square root of x over 1. Minus, what's the derivative of the bottom? Over 2 roots of x. Well, it's just the root of x, right? So I just wrote over 1, so when I multiply through later. Times root of x minus x. Each of those over 1. Divided by x, because if you square the square root of x, you get x. So let's clean up that numerator. Here we're going to get the square root of x times this. The square root of x's will cancel, correct? So we'll get 1 over 2 minus the square root of x minus, then, yep, 1/2. It'll be plus x over 2 roots of x all over x. What happens? 1/2 cancel. I get negative root of x plus x over 2 roots of x over x. You can't, this is a complex fraction right now. So this is x to the 1, and this is x to the 1/2. So what's that going to give me? Just x to the 1/2, right? So in other words, I get negative root of x over 1 minus the root of x over 2, or plus root of x over 2, all over x. What's the root of x over 1? Negative root of x over 1 plus the root of x over 2. How do I do that? So negative 2 roots of x plus the root of x, negative root of x over 2 over x over 1. Multiply by reciprocal, negative root of x over x, 2x, excuse me, x to the 1/2, x to the 1, 1 minus 1/2. 1/2, is it going to be in the numerator or denominator? Denominator. Yeah. Let's try one that's not a lot of work. Flip it over. Let's try F. So we'll use the quotient rule or the product rule. Quotient rule. Watch how nicely this works out. What's the derivative of the top? 0. And 0 times the bottom will give you 0. Minus, what's the derivative of the bottom? Times all over that quantity squared. So I've got two negatives here. It's going to make a positive, so it's like I get 36 x to the third plus 12x minus 3 over that 3x to the fourth plus 2x squared minus x quantity squared. So we showed you a few examples that involve algebra. Let's look at a few examples that don't involve algebra. I love this kind of a problem, and you'll see this kind of problem on my test, as well as the AP exam. So let's find the following. F minus g prime of 3. That means you take f prime of 3 minus g prime of 3. And as you look at the table here, it tells you given a certain x value, it'll tell you what f of x is, g of x, f prime of x, and g prime of x. What's f prime of 3? Minus g prime of 3? Negative 1. So it gives you negative 1. F plus g prime of 4. Should get 3. Now look at letter C. If you're not thinking properly, what would you do for C? F prime of 5, which is 3, times g prime of 5, which is 1, and you get 3. You can't do that. You can do that for addition, subtraction, but not for the product. So we have to use the product rule. The product rule says you take f prime of 5 times g of 5 plus g prime of 5 times f of 5. F prime of 5, g of 5, G prime of 5, F of 5. So see how I could test to see whether or not you understand the product rule without actually using algebra? There you go. You try letter D on your own. Should get 1/8. Everybody okay there? The paper you're working on, Kels. What's it about? What? Hieroglyphics. Yes. Wonderful. Ancient Egyptians. Special people. Can you read hieroglyphics? That would be cool. All right. Write an app for your phone that when you take a picture of hieroglyphic, it will translate it for you. There you go. $1 million. All right. Let's do example 4. Write an equation for a line tangent to curve at x equals 0. This is the type of problem that, again, you'll see on the AP test or my test. Great, great problem. I love it. Write an equation. So what 2 things should you write down? Slope and a point on a line. I know for a point on a line, I've got 0 as my x value. How do you figure out the y value? Plug in, I got 0 over 2, which is 0. Well, you know, you got 0 in the numerator, right? Just make sure you don't have 0 in the denominator. How about the line tangent the curve? I need slope. How do you find slope? Take the derivative. Derivative tells us the slope at any given point on the curve. What rule will I have to use to take the derivative? Quotient rule. What's the derivative at the top? 4 times x cubed minus x plus 2 minus, what's the derivative of the bottom? Three x squared minus 1 times the top, which is 4x. All over now. Does the problem ask you to simplify the derivative? No. So I don't have to worry about simplifying that. All I have to do is plug in 0. Don't waste time trying to simplify it. Just plug in your 0 right now. You get 4 times 2 minus -1 times 0. And on the bottom, you got 2 squared, right? So it looks like we've got 8 minus 0 over 4, which is 2. Y-intercept is 0, so y equals 2x. Done. Is that nice? Now, I don't know how many times I put this type of question on the test, and a fourth of you, a third of you, well, you'll multiply the whole stinking thing out. Don't do it. That's not why I'm asking you the question. So what I said is this year, instead of putting a problem where it's a, say, 4-part polynomial times a trinomial, maybe I'll put like 17 parts times 6 parts so that maybe you won't actually try to multiply it out. But that might confuse you as well. So let's just, again, try to work through it. And we're not going to multiply the whole thing out. Our point on our line is going to be 0. How do I find my y value? Plug it in. You're going to get 0 plus 3 is 3. 0 plus 1 is 1. Multiply, you get 3. Other things people do, they'll take the 3 and add the 1. It's times. Okay, so I got 0, 3. So now I got to find the slope. How do you find slope? When in doubt, take the derivative. 4x cubed. 15x squared minus 6. Times x squared minus x plus 1. What's the derivative of the second part? 2x minus 1. We got x to the fourth plus 5x cubed minus 6x plus 3. Now what? Plug in 0. We get a negative 6 times 1 plus negative 1 times 3. So negative 6 plus negative 3 is negative 9. So y is negative 9x plus 3. So again, I could test to see if you understand the product rule and the quotient rule without having you do just a ton of algebra work in terms of simplifying. We good? Leaves are blowing. It's such a special time of year. You know, Will Kozlowski came back and I asked him, you know, what are some things you miss about Albert Lee? He says, I just miss, you know, seeing green. You know, he's kind of out in the desert in California, and you just take for granted this time of year. But if you spend a fall or a year away from Minnesota, you'll just be amazed to come back and just see, you know, the beautiful fall that we have. So we're very fortunate. Great time of year. Get out and take a walk. I proposed to my wife on kind of the last nice day of fall. I looked at I was saving up money for a ring, and finally when the ring got done, I looked for a day where it was going to be nice and sunny outside and there was still going to be some leaves. And after that, I just went in the tank. Like the next day, I think we had snow the next day. So it was, worked out. Yeah. It was November 16th. So we got married the following August. We started dating so that was November. We started dating in March that year. So what do the YouTube people care? All right. Here we go. So I've showed you algebra. I've showed you. Is showed you a word? Is that showed? Shown. I've shown you algebra. I've shown you a table. Now I'm going to show you a graphical approach. F plus G prime of 3. Well, that's going to be F prime of 3 plus G prime of 3. And here's the two graphs I have. I have F and I have G. Who could tell me what F prime of 3 is? That's F of 3. I want to know what F prime. F prime means the slope. I want to know the slope. How'd you get 2, Dr. Dulitz? You just look at it. Okay, well, maybe you would say this point here is 2, negative 2. It looks like I rise 2 and run 1, so the slope is 2. Good. So 2 plus, what's the slope of G at 3? Negative 1, so you get 1. So figuring out these two slopes is important. You guys could see that if they ask that type of a question on AP exam, you could see why people would get confused, right? These really aren't that difficult of questions, but understanding it in the context in which it's asked, that's tough. Now, when you get to May, are you going to reference back to this point in time? Maybe not. We'll see. We'll try. You're going to try your very first AP practice problems on Wednesday. We'll see how you do. Okay, we got G minus F of 3. So we're going to take G of 3 G prime of 3, excuse me, minus F prime of 3. Or negative 1 minus 2 is negative 3. So then C is different. I have to take G prime of 3 times F of 3 plus F prime of 3 times G of 3. What's G prime of 3? Negative 1. What's F of 3? 0 plus dose times 4. Are you sure about that? G of 3 looks like it has a value of 4. Very good. It's right here. Good work. So I get 8. So then for the last one, I've got F prime of 3 times G of 3 minus G prime of 3 times F of 3 divided by G of 3 quantity squared. Well, we know the first part is 2 times 4. The second part is negative 1 times 0. And G of 3 was 4, so squared is 16. So I get 8 over 16, which is a half. Right? Okay. You're going to hate me when you see your assignment. But tomorrow, your assignment's going to be super short tomorrow, and we're going to have no notes. You're done with the notes. But tomorrow I have to have you practice some problems because I'm afraid you maybe don't know them well enough. So, it looks longer than what it is. I know I just diced it up into, it would look smaller if I said 23 through 59, right? So I'll give you a choice. You can either do the blue one or the black one. You do the blue one or the black one. It's up to you. Maddie, we miss you. Catherine's crying right now. There's your assignment test on Tuesday next week, so we got a lot of time to prepare.